All right, welcome. Today we are going over 1.5 complex numbers. So you should remember doing complex numbers in Algebra 2. If you had me last year for Algebra 2, we definitely went over some of those. So mainly when we're looking at complex numbers, we should remember that it's trying to find a solution for a quadratic equation. And when you're looking at a quadratic, if you get an answer that comes out to have a negative underneath a square root, then you should know that that's going to be a complex number. So we know that the square root of -1 is equal to I, or it's an imaginary number, or imaginary unit. So whenever we have that negative underneath the square root, we always take out the I, the imaginary number. So right here, we should know this is a quadratic, because a quadratic always has an x squared term. Okay, so this is a quadratic, so if we go ahead and try and solve this here, we'll get x squared equals -4. When I try and take the square root of this, I'll get x is equal to, well, I have the square root of -1 and the square root of 4. So this is going to leave us with the square root of 4 is a plus or minus 2, and the square root of a -1 we now know is an I. Alright, so that is an imaginary solution. So let's take a look here. Our imaginary unit, I, is the square root of -1. We just went over that. And this is our imaginary part. When we put the real number and an imaginary part together, this is called a complex number. So your A is the real number. Capital R with a line through it means real number. Okay, not hashtag, number. And BI is your imaginary number. So together, this is a complex number. So before we move on anymore, let's go ahead and take a look at, well, we just said we have an I. And if I have an I, and I know that's equal to a -1, if I take this and I square both sides here, what happens is I'm going to get I squared is equal to, we should know that the square root and the squared will cancel each other out, and therefore I squared is equal to -1. Okay, so I squared is equal to a -1. If we go ahead and we try and find I cubed, well, I cubed, we could break this up knowing our exponent properties. We know that this can be written as I squared times I to the first, because when I'm multiplying and I have the same base, you add the exponents. 2 plus 1 is 3. We just found out that I squared is a -1. So therefore, I squared is a -1 times I. Well, that means that I cubed is really equal to a -I. So I cubed, that's equal to a -I. All right, I to the 4th. Well, I to the 4th here, we can again break this up as I squared times I squared. And again, we know that I squared is a -1 times a -1. Therefore, I to the 4th is equal to -1 times -1 is 1. And we can keep doing this. So if I did I to the 5th here, well, that's really just I cubed times I squared, because 3 plus 2 is a 5. We add the exponents here. I to the 3rd, we just said, is a -I. And then I squared is a -1. And that is, you could do this a bunch of different ways. A negative times a negative is a positive. So therefore, that's just an I. So I to the 5th is really I. You also could have broken up I to the 5th as I to the 1st times I to the 4th. That's just I to the 1st is an I. I to the 4th we found is a 1. I times 1 is I. So you could do this. There's not just one way to break these up. So this is also equal to I to the 5th. And you can get into bigger ones. Like if we did, let's say, I to the 21st. Well, I to the 21st is I to the 20th times I to the 1st. Right? 20 plus 1 is 21. I to the 20th, again using my exponent rules, I'm going to write that as I to the 4th to the 5th, bringing down that I. Because when I have an exponent inside and outside, I multiply these, and 4 times 5 is 20. I to the 4th, again, is a 1. 1 to the 5th, well, we should all be able to do that. 1 to the 5th is a 1, and 1 times I, that's an I. Therefore, I to the 21st is, we just proved it to be I. Okay, we're going to be using these a lot. The main one, though, is I squared equals -1, and of course, I is equal to the square root of -1. All right, here we go. Adding and subtracting complex numbers. So, we're going to be adding the real parts together, 3 plus 2, 5, and the imaginary parts together, -I plus 3I, or 3 minus 1, is a 2I. All done. Again, here we're going to combine our imaginary parts. Well, these will just cancel. 2I minus 2I cancels, and we're just left with a -4. So it's just a real number there. Okay, multiplying complex numbers gets a little bit more detailed, but still not hard. We're going to start by distributing this 4 in. 4 times -2, -8. 4 times 3 is 12I. All done there. I times I is a -3I squared. And we just said that I squared is equal to -1 because I is equal to the square root of -1. So this is really a -3 times a -1, which is a 3. There we go. This one here, when we have two binomials, we FOIL, right, to make sure we multiply everything out. So when I FOIL this, I'll go first, 2 times 4, outer, 2 times 3 is a 6I, inner is a -4I, and last is a -3I squared. Using again that I squared, it's going to keep coming up. We have an 6I minus 4I is a 2I. This is a -3 times a -1 is a +3. 8 plus 3 is an 11 plus 2I. So make sure that you're writing it in the form of A plus BI. Okay. These two are actually called conjugates. We're going to get to that in a little bit. And that's when we have just these two signs are different and everything else is the same. So we're going to multiply this whole thing out by using FOIL, but we're also going to learn that in the end, the outer and the inner terms are always going to cancel out when you are multiplying conjugates. So here we go. We go first, 3 times 3, 9. Outer is a -6I, inner is a +6I, and last is a -4I squared. So you can see that these are opposites, the -6I and the 6I. So those cancel. Then we have a 9, a -4 times a -1. I squared is -1. 9 plus 4 is a 13. There we go. So notice that we didn't have any imaginary number left. That's important because we're going to use that a lot when we start dividing complex numbers. All right, you guys are going to give this one a try on your own, see how you do with that. All right, so hopefully you gave that a try. Noticing that 3 plus 2I squared is the same as writing 3 plus 2I times 3 plus 2I. All right, so again, we're going to FOIL it. We go first, 3 times 3, 9. Outer is a 6I, inner is a 6I, and last is a plus 4i squared. This is a 9 plus 12i plus 4 times a negative 1 is really a negative 4. Okay, so this is a 9 minus a 4 is a 5 plus 12i. Hopefully we got that as our answer. All right, moving on. Here's what I was talking about with the complex conjugates. So with complex conjugates, notice just these middle, the second term is changing. So if I go ahead and I take these and I multiply them out, you're going to see that the outer and inner, when we try and FOIL it, will always cancel out. So let's give it a try. First, a squared. Outer, we're going to get a negative ABI. Inner, we're going to get a positive ABI. And then last, I'm going to get a negative B squared I squared. Okay, so look what happens here. Negative ABI plus ABI. Those are going to cancel out because they are opposites of each other. And that was the outer and the inner terms. That will always happen when you have conjugates. All right? So continuing on, I have an a squared minus b squared. I squared is a negative 1. So therefore, we get a squared plus b squared. And there it is. All right, sorry about the bell. When we're dividing complex numbers, we're going to be multiplying this by, we're going to multiply the top and bottom by the conjugate because that will get rid of the imaginary solution in the denominator. So for this one here, we're going to have 1 minus I, because that is a conjugate and it will get rid of our imaginary solution. So in the numerator, it's just multiplied by 1, so it's just 1 minus I. And in the denominator, I only have to multiply the first and the last terms. I times negative I is a negative I squared. Okay, and we know that negative I squared is a negative 1. 1 minus negative 1 is a 1 plus 1. Therefore, you get 1 minus I over 2. You can leave it like this. Or if you want, you can write it as 1/2 minus 1/2 I. Both of those are good. All right, this one here, let's give this one a try as well. Multiplying it by the conjugate, we have a 4 plus 2i, a 4 plus 2i. The numerator we do have to FOIL, okay, because those are not, the numerator is not, those are not conjugates. So we'll do that. We go first, outer is a 4i, inner is a 12i, and last is a 6i squared. All over, we're only going to multiply the first and last for our denominators. The first is a 16, and the last is a negative 4i squared. All right, simplifying this a little bit more, we have, well, 6 times I squared, that's a 6 times a negative 1, which is a negative 6. So we have 8 minus a 6 is a 2. 4i and 12i, that will give us a 16i. All over, this is a negative 4 times a negative 1 is a plus 4, so 16 plus 4 is a 20. Okay, we could take a 2 out of everything. We get 1 plus 8i all over 10. Here we go. Okay, and let's see. You can also simplify it a little bit more if you want, or you can leave it like that. So if we did simplify it more, that would be 1/10 plus 8/10 I. And this part can be simplified more. We can take out a 2 from both of those and come out with, taking a 2 out of from the 8, we get a 4. Taking a 2 out from the 10, we get a 5. So this is really the simplified version there. All right, your turn to try it out. Notice that it's squared, so be careful here. Okay, so hopefully you tried that out. We know that if it was just a 3 plus 2i, we would multiply that by the conjugate of 3 minus 2i, and that would give us a 9, our first, and then our outer will be a negative 4i squared, which is really a 9 plus 4 because I squared is a negative 1, and negative 4 times negative 1 is 4. So that's a 13. So in the denominator, we really want to be multiplying by 3 plus 2i squared times 3 minus 2i squared. Because we can think of this as a 3 plus 2i times its conjugate, take one of these, 3 minus 2i, take the other one of this, 3 plus 2i, 3 minus 2i. Okay, so this part here became a 13. This part here became a 13, which will give us a 169. So in the denominator here, we have a 169. In the numerator, well, I should actually go ahead and erase this so we can write down what we're multiplying it by. Okay, so for the numerator and the denominator, we're multiplying it by 3 minus 2i squared. 3 minus 2i squared. So if we did some side work, we had to multiply out 3 minus 2i squared is 3 minus 2i times 3 minus 2i. That will give us, our first is a 9, outer is a 6i, inner is a 6i, and our last is a 4i squared. Okay, so that's really a 9 minus 12i. This will become a minus 4, so a 5 minus 12i. So this is really, this is times here. Sorry about that. This is really 5i times 5 minus 12i all over our 169 that we found from before. Distributing in this 5i here, we get 25i, minus 60i squared over 169. That will be a 25i, 60 times a negative 1, so that's a plus 60 all over 169. And there we go. A little long, but not too difficult. All right, let's take a look at this definition. So we know that we can break up square roots, but it has to be when it's under certain rules. So it does not apply when these are both negative. So, for example, if I have the square root of negative 5 times the square root of negative 5, I have to first take out this negative. So this is really going to be the I square root of 5 times I square root of 5. That's going to give me I squared, square root of 25. We know that when we multiply two radicals, they have the same root of 2, and it's really just what there is underneath, the radicand. So this is really an I squared times 5 using the principal root of the positive value. And I squared is a negative 1, so therefore we get a negative 5. So if these are both negative, you need to take out the i's first. Okay? So let's give some of those a try here. So just like with this one, this will be I square root of 3 times I square root of 12. This will be an I squared square root of 3 times 12, that's a 36. And then we have a negative 1 times 6 is a negative 6. Okay, this one here, it's the same when you're subtracting. So for this one, this will be an I. We can actually break this up and say, what's a perfect square that goes into 48? That's a 6. 16 is a perfect square that also goes into 48. So this will be a 16 and a 3. Minus, we have an I here, and we say what's a perfect square that goes into 27? It's a 9 times 3. So square root of 16, the principal root, is a 4i square root of 3 minus 3i square root of 3. 4i minus 3i is going to be a total of I square root of 3. Okay, and then finally, finding complex solutions. So this is the one where if we are going to be looking at a parabola, this is just telling me to go up 3 units. So if you notice here, it's not crossing my x-axis at all. So it's going up 3 units, and therefore, if it's not crossing your x-axis, you're going to come out with a complex solution for your answer. So if I subtract 3 here, this will be x squared equals a negative 3. Taking the square root of both sides here, I get plus or minus I square root of 3. Okay, this one, it cannot be factored, so you're going to have to use the quadratic formula, or you can use completing the square. Let's go with the quadratic formula for now, especially since your a is not 1. If you don't know it, you should learn the song. Makes it nice and easy. Here we go. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, it's helpful to write down what a, b, and c are. And this is in standard form of my ax squared plus bx plus c. So here we go, plugging in. We get x equals negative 2 is a positive 2, plus or minus negative 2 squared is a 4, minus 4 times 3 times 5. All over, sorry, my crooked lines, 2 times 3 is a 6. Simplifying this here, I'll have 2 plus or minus the square root of 4 minus, well, 4 times 5 is 20, and 20 times 3 is a 60. That's obviously going to come out to be a negative value. Okay, coming up here, I get 2 plus or minus the square root of, well, 4 minus 60, that's going to give me a negative 56 all over 6. I'm going to take out my I here. Oops. Taking out, so I have 2 plus or minus. I need to simplify the 56. So 4 goes into 56. So I'm going to write this as the square root of negative 4, square root, square root of negative 4, square root of 14, because negative 4 times 14 is 56. Okay. And that is all over 6. So I get 2 plus or minus, the square root of negative 4 is a 2i, the square root of 14 over 6. I can simplify a little bit more by taking out a 2 from everything, so I'll be left with a 1 plus or minus I square root of 14 all over 3. This is our solution. It's a complex number. There's 2 solutions here because it's a plus and a minus. This is also telling us that it will not cross your x-axis if we were going to graph this quadratic and make the parabola. All right, here's your homework. Give that a shot. Thanks for listening. Have fun with it.